the dress materials to entangle it, to tighten it, and some cushioning effect. So you can see over here, you have the uh, locking system. Of course, you may say you don't have a 3D printer. So of course, you can go with this system. Very simple A4 sheet, maybe cardboard sheet setup over here. You can use that. You can keep your mobile cameras over here. Maybe protect it. Activate the virtual tour over here, and then maybe use the rope system and try to connect it. So what we are trying to do over here is and see what if he would have come to NITK and performed the experiments like how his seniors did it. So that is what we tried to do during the breakdown, where we really had a problem of trying to do the best to the students. Now, suppose if the student already has something device like this is a ready-made device wherein which he can connect a Samsung phone, and of course it comes with all the controllers. And suppose if he has even better, because nowadays people are into AR and VR, you can devices that we call it as Oculus Rift, and of course you can get the sound feedback and all those things and then try to do. So basically it's something like this. You connect it over here, and this can be connected to the HDMI monitor or your laptop output, and then try to use it. Of course this becomes an expensive device, but still works with a small device that is made in-house. Maybe students knows how to cut a sheet of paper wherein which the template is being given, and just fix two convex lenses and then get that virtual reality thing into it. So now it may be a simple laser cut devices which is over here, which can be used, or it can be a paper cut device over here, or it can be a 3D printed device, something like this, or an ready-made high-end devices which are made from Samsung or any other company like Oculus Rift, HTC Vive. Whichever device be able to experience the lab. So let me just share the screen once again. I hope my voice was audible.
Yes, sir.
Oh,
Audible.
yeah. So now let me go back to that screen wherein which the virtual tool setup was there, and yeah. Now this is like basically so the students will come to know, oh, this big is setup. Now from there, we wanted to link into the simulator. With the last session, you had a demo wherein which students were trying to, our staff showed you how the setup is being done, how the simulation can happen, and other things. So now what we'll do is from here we can click on to the simulator. So I'll just so it goes into the simulation page wherein which the simulation can be done. Of course, here we have intentionally kept an line diagram. The question comes, why this line diagram is when we tried all over India, and when we did it, some of the students are with a very poor network, and government was trying to give Akash tablets to the public, and which had a very least configuration. Now we talk of phone with 8 GB RAM, and whereas Akash tablets may not be having such kind of facility, or the network may be low. So their objective was give the best with the lowest configuration things. Of course, with this, he is able to understand what VNotch is, and then he'll be able to get some identification of the colors. If even water flows we have like over here, so he's trying to use the hook gauge and identify us that is what the water is and try. Of course, nowadays the current generation, some of the students would like to get screen. So you see we have a very simple screen over here with the line diagram, and this is where the values are. Maybe I'll just enter a dummy value. Of course, this is all explained to you in the last session, but how shall we make this even more compact and give to students as an small spoken tutorial. So for that, what we did was we came up with this small video which explains what it is.
In this instant age, nobody has the patience to sit around and read or learn quietly, taking in all the information. Lagupata, developed by Center for System Design, NITK Surathkal, serves the same purpose. Lagupata in Sanskrit refers to teachings in concise form. It is a very short and apt video tutorial.
We created something called as small tutorials, which will help you to help students to get the information of conducting the experiment at a very short period. And so for that, so I was discussing about the tutorials. So this is a small tutorial on how an experiment can be done. So there are two phases in it. One is the actual setup, how the actual setup looks like, and how that experiment can be done. And there is another tutorial where in which we explain the students how a simulation can be done. So there are two ways in which that happens. Can be done. So there are two ways in which that happens. So I'll just showcase one of the lab, maybe a video tutorial. So this is a spoken tutorial where in which it shows how a simulation can be done. So hardly it is around uh, like within a 5 minutes we have made a concise tutorial for that simulation what has been developed. And suppose student is not able to visualize it properly, according the same setup, there is a video tutorial for a student to identify impact of jet. So maybe here you can see impact of jet, same setup within video tutorial with the staffs operating it, and they are trying to perform. So this I'm sharing that screen over here.
Impact of jet on wheels. This is the experimental setup. The objective is to determine of impact of jets on the wheels.
So this is the actual setup is visible, and the simulation is almost the tracing of that same setup what we have, so that students will feel what exactly it is.
Of vein, that is flat vein or inclined vein or hemispherical vein. We have set flat vein to the apparatus.
So you can see over here, they are showcase spirit level is kept, how the measurement is done, how are you going to balance that, so that the difference is they are not able to operate these machines. So now what we did was, suppose if you go into this simulation, so basically this setup over here. So from here, maybe if you think of the rectangular notch, from the rectangular notch or the V notch, you will be able to go to the video tutorial, you will be able to go into the Lagupata of that is the small tutorial, and from there you will be able to link onto the simulator. So that is what we now, what more than this can be given, and how we can make our students to perform even better. So we had initially the Moodle. From Moodle, they had access to all the features. From there, we made this virtual reality and the virtual tour. From there, we gave the links to the Lagupata video tutorials, experimentation demo, and the simulator. So for that, trying someone to speak with me.
ತಗೊಳ್ಳಿ ಅನ್ನ
See, I request all of you to mute yourself.
Yes, Vishnu.
What is now? The session is not ended, right?
Yeah, even I am not sure what exactly happened. I think Sir got disconnected. I think Sir got disconnected in between.
Okay.
Yeah.
I think you can ask people to stay on here, right?
Okay. Yeah.
Okay.
The session will be continued. There is a technical issue. Sir will be joining, but it ended. So I will be continuing the session. So.
Is my voice audible?
Yes, sir.
Yes, sir.
So now, how to give the students with even more better of the facility. So for that, we try to showcase an remote trigger lab, where in which they will be able to trigger our setup and perform experiments. So for that, I'll just demonstrate one of the one of the experiment called torsion testing machine. If the to the devices, we can trigger that. So now if you see, I am using
Yes,
the
Vishnu.
mobile to connect, and I will
I'll be
see whether
sharing
the live
through
stream
email.
can
So Rashmi
trigger.
wrote she will be joining at the end to mention about that. No, no, we will be connecting. I have prepared the form.
Um,
So we will be
so
sending it by email to the registered people.
yeah, so you can see the live stream that is there,
Okay.
the device, and from there I'll be able to trigger it. So now you can see over here the device, the distortion testing machine, and from anywhere in the world, people can students can sit and use any operating system and try to operate this machine. So now this was the next advanced level of remote access. We call it as RT labs or smart lab technology that we have integrated over here. Now, suppose if you see, I just showed an enlarged view over here. We can see the left side. You can see the device is getting rotated, and I'll just minimize the screen. Suppose if that is not visible, uh, you can see over here that the it's keep on rotating, and we will be able to get the torque versus angle. And now maybe this is almost the yield value, and after yield maybe you can get the ultimate and then the failure.
Thank you very much, sir. So we are coming to the close of our session today. So if there are any further more questions, they can be put forward at this point.
uh, 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 Vikyat Kathy has asked a question on what about other labs. Basically these two are the labs where in which the current lab classes are happening, and they needed a virtual reality and other things, for which we have done. There are some other mechanical labs also. Today's stream was civil, so classes are happening. For that we have created the virtual tour, virtual reality, and Lagopata, and the spoken tutorials for it, which is nothing but a Lagopata for the screen gap and experimentations. Geotechnical lab, it is available in the development stage. Jivita KN has asked a question: can remote trigger be triggered by everybody? Yes, a destructive test we requires scheduling, because now and then you can the samples can break if everybody is given an access. So based on schedule, we make the apparatus to be operated, whereas the non-destructive test mechanical vibrations related. So all those are accessible 21 during the mechanical sessions for tomorrow. It will be showcased. So you can see in the screen telling that the sample has failed. Regarding CAD labs, we have not done any simulations yet, because basically they are comparative support, for which we don't entertain using any proprietary softwares. So none of the simulations uses an proprietary softwares. Everything is completely open source, either for a tracing or getting the database or storing the data sets. Everything is in using open source techniques. Some of the softwares that is used for CADs is all proprietary, which is experiment is done in a BTech level. We can't ask her to put any type of flat plates or any type of his own design curved plates. Can't be done. Of course, what we do is he wants to test its own material. He can ship to us, and which we can operate it. And then give him a schedule operating rights, and he can operate and show. So I hope you have got what you had asked for. See, simulations, first it's a regular lab. Basically, we are trying to give them access for a regular lab. So the regular lab goes with the standard materials, maybe a tension rod of that is prepared in mass by the college officials, which is being tested. Now, if a student, yes, there are students from past many years and people who are accessing it, they have tested, given their samples, which we have connected and kept. We give them the rights to operate remotely, and they have performed, they have got. But when it is regular class, it is a standard materials, standard samples level, which can be seen in the mechanical division, wherein which the parameters can be changed. But too many parameters, it's hard to be replaced in civil engineering stream. Suppose if I take an tension test on a mild steel rod, wherein which a mild steel's property I have to change. So that we are not able to do in this phase. Why? Because it is interlinked to the remote trigger setups. Unless we mass manufacture so many parameters based materials with changing the composition of it, which is was not the objective. Whereas the objective of the virtual lab in the initial phase 1 and phase 2 was give as many setup to the public in mass, wherein which the materials are standard.
Good evening, sir. I'm Vikhyat, who's been texting you. Thank you for the information. What I meant was, I wasn't talking about research per se. What I meant about input and output is, if the virtual lab is created in such a way, like you gave the example of mild steel testing, right now what is available is, there is animation shows or a mild steel bar being put in tension and it breaks. But I don't think the student is going to learn much looking at that. Rather, if you could have a mild steel, if that experience is done in virtual lab, that would really help, especially this time.
My question is, what is missing? If you can, because I am not able to get what is actually missing.
For example, sir, if you look at the vibrations lab or the dynamics lab, there something called as.
Let us talk. Can we do with? Okay, tell me.
There, what happens is something called as mode shape experiment is there, where only a simulation is there, an animation is there. You're not actually inputting some parameters like changing the masses and stiffnesses or anything like that. Only a structure is there which shakes in different modes, and that is all that is there. It is like a video, and that is all you get to see there.
I don't think so. Why? Because there is explore, experiment, and Beryl, can you share that?
And you have the controls here, and if you want to see the graph has been displayed on RPM and height. And if you go to experiment, this is the explore phase where you can go to calculation part, or else you can also proceed with the identification of parts. So if you go with calculation, you can start the experiment, and the first thing is to find the RPM. So you can, for now I'm entering a dummy value, and you can check your result where your correct answer will be displayed. So either you can exit the experiment, or if you feel that your answer was wrong and you want to perform it again, you can reset the experiment. And again, you can see here every time you reset, the parameters would be different. For now the parameter is to find the height. So this was about mechanical engineering. So if you go to broad areas under mechanical engineering and labs developed by NITK, you can find dynamics of machine, which is having explore and experiment phase.
Do you have something in civil that you could demonstrate in the same way? Because in civil I don't find anywhere where you really give this in.
No, you are not supposed to give the input. Why? The my steel rod is constant.
Okay, so that is fine, sir. What I'm saying is, along with that, there should be a graph that explains what is exactly happening. Not just an animation.
Yes, I agree. Aishwarya, can you put to the graph plot?
Yes.
Where the database is coming.
Okay. If you go with input materials. So you can go with any one of the experiments here and show you the procedure part where the graph has been displayed, or else we can carry out the simulation as well. So you can see here the graph of load versus ivory scale reading is being displayed here, and also load versus extensometer. This will be displayed once you're done with the experiment. You have an option
So
to
if you
download
if you see this screen wherein which the data is getting populated, Aishwarya, can you just go on the just one step ahead, one scroll ahead?
Yes, sir.
Yeah. So here, when the UTM is getting loaded, it may be an animation, but you have a set of database that is getting populated along with the UTM point scale reading. Next to it, you can see. So this is where they reset it. And so this is where the actual reading comes. So around, of course, this is an analog device. The students who are noting down the values. So we can see that the database is getting populated. And when the experiment is done and when the cup and cone formation comes, so you need to stop, download the data if you want, it gets stored. And if you don't want, and if you go, you can just go over here. And this is the plot that actually comes from that data what you just did. And you can see the graph as well as when from there you can plot the best fit line and get the slope. Of course, if you see these data sets are that real, and you can see that there are small ups and downs that comes. And from there you can go to the post processing, measure the neck diameter, find the percentage reduction in area, find the percentage elongation, and fill in the values so that you will be able to get the thing. So here also what happens is here she is entering the dummy values, and the actual values will be showcased from the experiment that you got now. Maybe you just do another trial, the modulus of elasticity may not be 213 or 19, it may be something else.
Okay, so this test is there, sir. But as I said, along with this, we tried survey also, and survey honestly speaking was not.
Yeah, correct. Survey was actually done by IIT Roorkee. Then I am not sure about. We'll get back to you.
So which labs are presently all experiments in all the labs are working for? Civil, sir, civil.
So we can tell about NITK.
Okay.
So can go to the things and then go to NITK. So physical metallurgy, that is developed by NITK. And only civil you focus. Focus only on civil.
So metallurgy and mining labs are the labs under development right now.
Transportation lab is in transportation lab we have developed. Then marine structures lab. Then geology, environment 1, environment 2, the strength of materials, fluid machinery, fluid mechanics. So these are all these are the labs that is developed by NITK. You can see over here: engineering, environment 2, environment, fluid machinery, mining, geology, marine structures, transportation. It's all done by. And you can also see, if you click on it, you also see the teams that were involved. Is there any way that we can no, basically that is not been implemented by the main coordinating group? The question asked by Nritya. No, because it is, as this is all open to public, anybody can use, not only to engineering group. So as of now, this does not have a login and monitoring session. So what we basically do is we do the post analysis. We see them to plot the graph and share it to us in the Moodle, and that is where we evaluate them. And there will be post quiz and pre quiz. Kathy will consider that survey lab thing because that was not assigned to us. If we get a chance, we'll try to develop it and try to give and more. It can develop and the screen.
Yes, sir. Yes, sir.
Yeah.
Thank you, sir.
Yeah. Share the lab wherein which there is testing on aggregates.
Okay.
Or
so
materials.
Okay, this is one of the lab that is transportation. One more lab is marine structures. So you can see the test on specific gravity, fineness, modulus, standard consistency, and initial setting has been displayed. So this is about standard consistency. And if you want to go with specific gravity, you have the test of cement, aggregate, fine aggregate, and coarse aggregate. So you can select either one and proceed with the simulation.
Wherever required, we have added few colors. Others we have kept it as simple as possible. Why? Because not every student may be having to a good computing device. So that was the main reason. Maybe geology lab, if you go, you have the 3D view and interactive session on and materials wherein which color is required. Maybe over here sand color is required, or in the environment lab when the color agent you add, you need a color to be changed. So wherever least possible we have done, so that still it will be able to load, because anything more than 5 seconds for an image to be loaded, they are treating it as slow by the review committee. So that was the objective. Because at the inside the college you may have a better facility, but outside the world, outside the thing wherein which students are now at a remote location, there was an issue. So for that reason, the color was kept to the lowest possible. That is why you can find most of them are black and white lines, and wherever only required, like as seen in the screen, is been given as color. Anything else? Okay, then Beryl, that's it from my side. I overshooted the time, and thanks for all the participants, faculties from different institutes for being at and clarifying your doubts. Feedbacks are taken in a positive way and it will be implemented for the betterment of the society. Thank you, Mohinder. Over to you.
Thank you, sir. So we are coming to the close of this session. So Rashmi ma'am, are you there? Or Purnima ma'am?
Thank you, sir, for the wonderful session.
Thank you.
Thank you, sir. Thank you very much.